The purpose of this presentation is to provide a quick overview of the coordinate conversion from the horizon coordinate system to the equatorial coordinate system, primarily for radio astronomy, but obviously applicable to any sky position. One of the basic activities for anyone dealing with astronomy or radio astronomy is the determination of an object's position in the sky. There are three basic coordinate systems in use: horizon coordinates, which are altitude and azimuth; equatorial coordinates, which are right ascension and declination; and galactic coordinates, which are galactic longitude and galactic latitude. So for the conversion of these coordinate systems, primarily, as I discussed earlier, from the horizon coordinate system to the equatorial coordinate system, there are a couple ways, a couple simple ways to do this. One would be directly from trigonometry, and the other would be using the available programming language packages. In this case, we'll be talking about Python. And those packages include a number of packages, but the two that are, I think, most commonly used are probably astropy and phi-fm. In this discussion, we're going to talk about astropy. There are a lot of opinions about which package is best for the coordinate conversion, and not going to get into that, but we'll be talking about the coordinate conversion with astropy. If you're going to do it from trigonometry, of course, you have these steps that you see on the screen right now, and that involves a lot of individual calculations. You have to make sure you keep the units correct. You have to be very careful with each individual calculation. And as you can see, it would be time consuming and prone to human error. Certainly, you would not want to do this sort of thing if you were going to be doing any kind of tracking or anything that involved any kind of real-time information. But it is doable, and it is it just uses plain trigonometry. If you're going to do it on a real-time basis, where you're receiving real-time altitude and azimuth information from the encoders on a antenna mount or a telescope mount, you would want to try to use a computer with one of these high-level packages installed. And in this particular case, as I mentioned a few minutes ago, I'm going to be using astropy. You would load these packages. You would also have to enter the horizon coordinates, that is the altitude and azimuth, and in this case they're manually entered, but in a real system you would be getting those from the encoders on the mount. They would then process, this computer program would then process that, also having to enter your specific longitude and latitude along with your height above sea level, and the current time. That would then produce the real information, which then could be transformed either into your equatorial coordinates and your galactic coordinates. Those then would have to be converted to the proper form for use in your programs. This is the first part of that program. The second part of that program, just a continuation of the first actually, would then convert the information into a number of different forms, and I'll show you that in the next slide here. You can see we're looking at the time that this was all processed. We're looking at right ascension, both in degrees and in decimal hours, and in hours, minutes, and seconds, depending upon what it is you need. The same is true with declination, where you're looking at degrees and minutes and seconds. And the same is true for latitude and longitude, where there also you're looking at degrees, minutes, and seconds. So this is the quick just sort of rundown on how to do that with a computer system for a altitude and azimuth mount. Thank you very much.